Rahman Rahim, good morning. Today we'll talk about the atomic number and the mass number. What is the atomic number? Actually, let's talk about it here on this YouTube. Here they show us a part of the periodic table. As you see, above each element there is a number, and as you see, this number is going more and more and more in order, from 1 for hydrogen, then 2 for helium, then 3 for lithium, 4 for beryllium, 5 for brome, 6 for carbon, and so on. What is this number? That starts from 1 up to about the end of the periodic table, about 118. What is this number? Actually, this is the number of the protons in an element, in the atom of the element. Every element has its specific number of protons. No two elements have the same number of proton in their atoms at all. So it is a specific number. It is a specific property for the atom of the element. Okay, so as you see here, from that we can know that the hydrogen has 1 proton only. Lithium has 3 protons. Beryllium has 4 protons, and so on. Okay, now in the neutral atom, what is the very, very important property for protons and electrons? This is very, very stable in all atoms. In the neutral atom, the protons and the electrons are equal in the number. They are equal in the number. They have opposite charge. Protons are positive, electrons and negative, but they are equal in the number. And that's why we said in the last lesson, the atom has 0 overall charge, because they are equal in the number and opposite in the charge. Okay, so from knowing the proton number, the atom number, the atomic number, we can know also the electron number in the neutral atom. Okay, you will ask me, teacher, why they said the atomic number is the number of the protons? Why they don't say that it is the number of the electrons? I will tell you, because always the protons are they are stable in the nucleus. They don't move out of the nucleus. They can't be lost or gained from the atom, opposite to the electrons. As we said in the last period, that electrons can be lost or gained, and in that case the atom will be called ion. So there are some cases in which the electrons can be lost or gained. So we can't depend on them. We can't depend on the number of electrons. Only in the neutral atom, the electrons and the protons are equal. Okay, so how we can use this atomic number? For what? I can use it that only from looking at the periodic table, from the first look, from looking at the atomic number, I can know how many numbers are there, how many protons are there, how many electrons are there, and in the next number you will see that the number of electrons is very important to decide the activity, the reactivity of the atom, to give the valence number, something that you will learn in the next lesson, inshallah. For now, just memorize and put in your mind that the atomic number is the number of the protons, and we can take from it, or we can know from it also, the number of electrons in the neutral atom. This is for the atomic number. Then we will talk about the atomic mass, the mass number, because it has some difference from the atomic mass. You will see that in the next lesson. The mass number is the total number of protons and neutrons in the atom's nucleus. Why we need this mass number? Actually, because not all the atoms are having the same number of neutrons and protons. As what we said in the last period, we said that in some elements the atoms can have different number of neutrons. So, and they are called isotopes. Isotopes, like the chlorine, you will see that they write chlorine 17, chlorine 15. It means this refers to the different number of neutrons. Let's have some examples. I will give some examples in the next video, because I want to explain it by myself. Thank you. For example, this is the helium atom. As you see, it has 2 protons, 2 neutrons, 2 electrons. This is the helium, okay? 2 protons, 2 neutrons, 2 electrons. Okay, the last number that we learned, that was the atomic number. What is the atomic number here? The atomic number, what is it? We said the atomic number, not the atomic mass. The atomic number is the number of protons, only the number of protons, which is equal to the number of electrons in a neutral atom. So what is the atomic number here? It is 2. Now, the mass number. The mass number, we said, is the total number of protons and neutrons in an atom. So what is it here? What is it? Think and give the answer. Yes, the answer is 4. The mass number for the helium is 4. This is true. Some other elements, as the fluorine, okay, the fluorine can has different number of protons and neutrons. Look, it has 9 protons and 10 neutrons. So we can't depend on duplicating the number of protons at all. Here, the mass number is what? What is the mass number here? It is 9 plus 10. 9 plus 10, which is 19. The mass number is 19. Okay, how we can use this mass number? For what? We can use it to figure out what is the number of every subparticle in the atom. يعني we can depend on the mass number to figure out what how many protons do we have, how many electrons do we have, how many neutrons do we have. Like now we will see an example. This is another example here also. This is the aluminum. The aluminum has 14 neutrons, 13 protons. 14 neutrons, 13 protons. So what is the mass number? The mass number is 13 plus 14, as what you see here. We have 13 protons, 13 plus 14, which is equal to 27. This is the mass number. This is the mass number. Here we will see also another example about the chlorine. Yes, finished from the aluminum, 27. Yes, now the chlorine. The chlorine has 17 protons, 18 neutrons. 18 neutrons. So its mass number is 35, the total number of protons and neutrons. I think these examples are enough. But as what we said about the chlorine, that it has isotopes. We said the mass number of this chlorine here is 35 because it has 18 neutrons. But what about another isotope of the chlorine? It has 17 proton, 20 neutron, you see? So what is the mass number here? It is 37. Both are chlorine. Both are chlorine, you see? Yani the same element can have some atoms with 35, some atoms with 37. Okay? That's it. This is very important in the isotopes. Thank you. Please solve the lesson review, and on Sunday I will give you some other examples, or a special worksheet also about the atomic mass and the atomic number and the mass number. Thank you. Have a nice day.